this video, we want to understand exactly how rockets work. At first glance, rockets seem like almost a magical technology. The heaviest rocket ever launched was over 6 million pounds in weight, roughly as heavy as 1,500 cars, and yet it was launched into space. So how is such a heavy object able to rise so high to be able to break out of the Earth's atmosphere? It turns out that the basic principle governing the rocket's operation is actually relatively straightforward, and that's what we want to understand today, using some basic model rockets that we've built ourselves, and more importantly, that you can also build yourself. The basic principle that all rockets work by is the law of conservation of momentum, which, it turns out, is one of the most important ideas in all of physics. So let's quickly remember what conservation of momentum means. If we have some object, like the rocket drawn on the left of the screen, which has a mass m and is moving with a velocity v, then the object's momentum is defined to be the product of m and v, the product of the mass and the velocity. And the important thing about momentum is that if we have some system that's isolated from its environment, conservation of momentum tells us that the system's total momentum doesn't change as time goes on. That's why we say that momentum is conserved. So let's apply this to a situation which at first glance doesn't really seem to have anything to do with rockets, but will turn out to be quite relevant. So let's say we have a skater, who is some ice skater on some frictionless surface, who is holding a ball. So we have the skater, which has a mass ms, and the ball, which has a mass mb. And initially, both the skater and the ball are at rest. They're moving with zero velocity. Now here, what's the total momentum of the system? Well, we add up the momentum of the skater and the ball, but since they're both moving at zero velocity, the total momentum of the system is zero. What this tells us then, by conservation of momentum, is that at any other time we choose to look at the system, the total momentum of both the skater and the ball must be zero. But let's say that at some time the skater decides to throw the ball away from her. So we have now the ball moving at some speed v. If we just take into account the ball, the total momentum of the system is now the mass of the ball, mb, times v, which, as we can clearly see, is not zero. So, for momentum to still be conserved, to make the total momentum zero, the skater must now be moving backwards with some new velocity. So we draw the skater has this new velocity vr, or v recoil, and for that to come out to be zero, like we need by conservation of momentum, we find that v recoil is equal to mb over ms times the velocity of the ball. So let's step back and see what this actually told us. What this tells us is that if we have an object that somehow pushes away another object, the first object will get pushed right back because momentum is conserved. Now it's easy for us to understand rockets, because they work in exactly the same way as the skater with the ball. Except instead of throwing a ball, a rocket launches itself by ejecting some of its own mass downward. In fact, while a rocket is being accelerated upwards, its engine is continuously, all the time, ejecting some mass and forcing it downwards. Because this mass is forced downwards, by conservation of momentum, the rocket must then be forced upwards. To put it in terms of forces, the rocket has to exert some force on the ejected mass to push it downwards, which then results in an equal and opposite reaction force pushing the rocket upwards. And that's it. That's how conservation of momentum, or equivalently Newton's third law, underlies the launching of rockets. But how does this actually happen in a model rocket? It all occurs in this device shown here, which is the engine of our model rocket. If we could see the inside of the engine, it would look something like this. There are 3 different kinds of propellants which are all held inside the engine by some clay, which has an opening only on the downward facing side. And what we do when we launch the rocket is we put an igniter in the engine, which is just a piece of wire with a material that catches fire when we pass a current through it, which we do by hooking it up to a battery. So when the igniter catches fire, it ignites the propellant, which quickly turns from a solid into a hot gas, which bounces all around the engine and then escapes the only way it can, downwards. This results in a continuous ejection of fuel downwards, which is what propels the rocket upwards. And that's it. Now that we understand the theory of how a rocket works, let's take a look at a real rocket launch in action.